second lecture on magnetic materials. In the first lecture, we have seen about introduction to magnetic materials, and we have also seen about the different types of magnetic materials, that is diamagnetic, paramagnetic, ferromagnetic, perimagnetic materials, and comparison of dia, para and ferromagnetic materials and their important characteristics. Today's class will moving into second part of the lecture, wherein we will be discussing about the derivation of classical Langevin's theory of diamagnetism. So today's class exclusively we will be discussing about Langevin's classical theory of diamagnetism. So once again, diamagnetic materials are the materials which are having negative susceptibility. The chi or susceptibility is negative, and when these materials are placed in a magnetic field, they feel repulsion from the magnetic field. And diamagnetic materials, if a rod of diamagnetic material is suspended, then it will stand perpendicular to the direction of magnetic field. And if a material is placed, a liquid is placed in a watch glass on the magnetic pole, then we get a dip in the middle for diamagnetic liquids. And the diamagnetic properties have main characteristics that their susceptibility is negative. Now, with the very brief introduction about the magnetic materials, we will be moving on to a very important derivation of classical Langevin theory of diamagnetism. So it is basically, an atom in which a nucleus, you can look at the diagram, atom with nucleus at the center, and electron is revolving in a circular orbit. Electron is revolving around the nucleus, and nucleus, you know that there is a charge on the nucleus, it is positively charged, so there is Ze. Ze is the charge on the nucleus, Z is the number of positive charges, and E is 1 unit positive charge. So therefore charge on the nucleus is Ze, and electron is negatively charged. Electron is revolving around the nucleus. Orbit distance is r, radius r, and this electron of mass m, charge E, rotating about nucleus Ze in an orbit of radius r. Once it rotates, then it will have an angular velocity for the electron, that is omega naught is the angular velocity which is revolving. Then centrifugal force, once a body is rotating in a fixed orbit, then it will experience a centrifugal force. So we know that this force of mass m, velocity v, and r is radius, then this centrifugal force is given by mv square by r. A body rotating about a fixed object, that is electron revolving around the nucleus, where m is mass of electron, v is its velocity, r is the radius of the orbit, so centrifugal force. So this electron will experience a centrifugal force which is inwards, acting inwards, F naught, which is acting inwards. Now, we also know that V is R omega. V is, there is one relation, V is R omega. So if we substitute for V, then this F naught will become M omega naught square by R. So for V, it is R square omega square, R cancels. So F naught is equal to M omega naught square R. This is the first equation. And this being two objects, that is nucleus and electron, they are charged objects. They experience a electrostatic force of attraction between electron and nucleus, which is a Coulomb's law, and therefore this can also be written as Ze square. Ze is one charge, E is another charge, so therefore magnitude is Ze square by 4 pi epsilon naught r square. It is Coulomb's law. That is two charges separated by distance r. So electrostatic force of attraction F naught is Ze square by 4 pi epsilon naught r. So this force is acting inwards, whereas centrifugal force is acting outwards. If you compare equation 1 and 2, equation 1 and 2, say F naught is M omega naught square R, M omega naught square R, this is equal to Ze square by 4 pi epsilon naught R square. So then there will be an equilibrium balance between the centrifugal force and the electrostatic force of attraction. Therefore, the atom will be stable. If we rewrite this for omega naught, so this omega naught you can rewrite as square root of Ze square by 4 pi epsilon naught M, here R square plus this R, this becomes R cube. So this is very important expression which we will be using in the further steps. Omega naught is equal to square root of Ze square by 4 pi epsilon naught mr cube, or omega naught square is equal to Ze square by 4 pi epsilon naught mr cube. This is the third expression. Now, we are talking of response of magnetic field. Same atom, if it is placed in a magnetic field, external magnetic field, then it will experience some other force. So the magnetic moment of electron is M, magnetic moment, that is equal to current into area. So it is given by current into area. So current is E omega naught by 2 pi into area of the orbit is pi r square. Therefore magnetic moment will be E by 2 into omega naught r square. When you apply, see, first we are writing expression for magnetic moment as current into area. Current is E omega naught by 2 pi into pi r square. So E pi gets cancelled, E by 2 into omega naught r square by 2, or E omega naught r square by 2 is the magnetic moment of electron. So same atom, if it is placed, I was talking of an external magnetic field B. So if the atom is placed in an external magnetic field B, which is acting normal to the orbit. So if it is acting normal to the orbit as shown in the figure, say figure we have shown in the first figure, see if the field is acting perpendicular to the orbit, then there will be an additional force called a Lagrange force. Fl is a Lagrange force which is acting at perpendicular to the orbit. When the force is perpendicular, so the atom or electron will experience a Lagrange force. So this Lagrange force Fl is given by charge of the electron, because it is electron, minus sign, charge is E and it is V cross B. B is the applied magnetic field and V is the velocity of the electron. So V cross B minus E into V cross B is the Lorentz force which is acting normal to the orbit. When it acts in direction perpendicular, so we get FL as a Lorentz force minus E V cross B. So you can write magnitude as EVB sine theta, and theta is 90 degree, therefore sine 90 is 1. So it is EB R omega, because V is again R omega. So EB R omega sine theta, theta is 90 degree, therefore sine theta is 1. So it is EB R omega, V is replaced by R omega. So we get FL, Lorentz force, is equal to minus EB R omega. For stable condition, the mr omega square must be equal to Ze square. This is due to centrifugal force. This is due to Ze square by 4 pi epsilon naught r square is due to electrostatic Coulomb force plus this Lorentz force together. So we get stable condition for the atom. Mr omega square is equal to Ze square by 4 pi epsilon naught r square minus EBr omega. So we can rewrite this expression. So omega square, so you can take Mr this side, it becomes, and you can shift minus EBr omega to the other side plus EB omega by M minus this Ze square 4 pi epsilon naught. This Mr comes here, so it becomes Mr cube is equal to 0. So we are writing it for a particular form. We have rearranged the terms such that it is a standard quadratic equation, omega square plus EB by M omega minus Ze square by 4 pi epsilon naught Mr cube equal to 0 is a quadratic equation in omega. So we can solve this by standard method. So we can directly solve this. We know that omega is equal to minus B plus minus root of B square minus 4AC by 2A, where this is the standard form. So we are getting as omega is equal to minus EB by M plus minus square root of B is E. When you compare ABC, when you compare, so this is B, this is A, this is C. So A, B, C. So we can see A is equal to 1, B is minus B is my EB by M is B, this coefficient, this part is like B, A is 1, C is 4AC. 4AC is, A is also 1, 4, 1 into this bracket, that is Ze square by 4 pi epsilon naught Mr cube is C. So divided by 2A, A is also 1. So therefore omega is equal to minus B plus minus B square minus of minus plus 4AC by 2. So the solution we get plus minus root of omega naught square plus EB square by 2M under root minus EB by 2M. So if we solve this, we get this, and we will put a condition that EB by 2M is very small compared to omega naught. Therefore, in the under root, so this term is this term. Within the root, square of the small term is very small. So therefore we neglect. So this is equal to ಸ್ವಲ್ಪ ನೋಡ್ಬೇಕಾಗಿದೆ ಇವತ್ತಿಂದು ಹಾಫ್ ಇದ್ದೀನಿ ಮುಂದಿನ ಹೇಳ್ತೇನೆ. So the solution we have written in the standard form, plus minus under root omega naught square plus EB square by 2m, that is B square minus EB by 2m. So we are putting a condition here that EB by 2m is much smaller than omega naught. It is very small, its square is also small. Therefore, this bracket becomes root of omega naught square. Therefore, square root of omega naught square is omega naught minus EB by 2m as it is. So this expression is very important, which we are going to interpret. So we have written a quadratic expression in omega. So we have solved by roots and solution. We have put a condition that EB by 2m is compared to omega naught very small, and this EB by 2m within the square root is omega naught square. So therefore it is plus minus omega naught minus EB by 2m. So you concentrate on this equation. Omega is equal to plus minus omega naught minus EB by 2m. Now if you look at this equation is very interesting, and it says that omega and omega naught are different. Omega and omega naught are different. So omega naught is 1 when electron is angular frequency when there is no field. So when you apply an external magnetic field, the frequency of revolution of electron around the atom, frequency of revolution of electron around the nucleus inside the atom changes, then it becomes the omega. So omega is when you apply frequency of revolution, that is electron revolving around the nucleus per minute, its frequency revolutions around the nucleus is omega naught. When you apply external magnetic field, there is a change in frequency, this becomes omega. How it is related? Omega is equal to plus minus omega naught minus EB by 2m. So this omega and omega naught are differed by a factor EB by 2m. So this is very interesting. This factor EB by 2m minus EB by 2m, this factor is known as Larmor frequency. So how this omega and omega naught are changed? They are changed by a factor minus EB by 2m omega, EB by 2m. So this EB by 2m minus EB by 2m term is Larmor frequency. In the book, it is mentioned as Larmor theorem. So what is Larmor theorem is, Larmor frequency is this term minus E by 2mb. Larmor theorem, it says that omega, there is a plus minus sign when omega naught is plus, when omega naught is minus. So whenever the moments are parallel, then this sign will be plus. So there can be moments when you apply magnetic field, there will be an induced field. If the moments are parallel, then there will be a plus sign, and omega naught will have a different value. When there is a anti-parallel, moments are anti-parallel, then there will be another negative sign. So once again this value will be different. So omega and omega naught are angular frequencies are related by term EB by 2m minus EB by 2m is Larmor frequency, and when they are parallel, there is one value, anti-parallel another value. So this addition plus omega naught and minus omega naught is the Larmor theorem. So it is Larmor theorem. So the only term is Larmor frequency. So what we have understood is, whenever an atom is placed inside a magnetic field, so atom is having a nucleus at the center and electrons are revolving around the nucleus, and when you place this kind of atom, or when you apply an external magnetic field, there is change in the angular frequency of electron revolving around the orbit. So this frequency changes, because of that their properties and many other things also change. So then because of this change in revolution, change in fraction, so there is also a current induced. So this is what we are going to see in the next step. The change in frequency is minus EB by 4 pi m, and because of change in magnetic moment, change in frequency, there is a current induced in the atom. So therefore, delta m is equal to current into area. So E cross E, that is charge, into frequency of revolution is minus EB by 4 pi m, or change in frequency because of the external magnetic field minus EB by 4 pi m into pi r square area. On summing for all electrons, the induced magnetic moment delta m is equal to minus B E square. This is summation r square, radius of average radius of all the electrons, divided by 4m. If there are n atoms, n number of atoms per unit volume, so the per unit volume term is magnetization. So therefore, m, capital M, that is magnetization, is n number of atoms into magnetic moment Be square summation r square by 4m. All the electron orbits are not oriented normal to the magnetic field. So all orbits are not in a same direction normal to the electron field. Therefore, r square is taken as average or mean square radius of the orbit for all the electrons. And if we take z axis as the reference field axis, then we can replace r square by 2 by 3 r square. We can replace r square by 2 by 3 r square, and this m becomes, see, r square you replace by 2 by 3 r square. Therefore, n B E square summation r square, 2 cancels, so it becomes 6m. So magnetization is n B E square by summation r square by 6m. And the susceptibility is defined as m by h. So volume susceptibility of a material is defined as m by h. So m we have just now derived, that is nb square sigma r square by 6m divided by h is chi is equal to m by h. So this nbe square by summation r square sigma mh, or minus mu naught, where B, for B we are writing as mu naught H. So for B we are writing as mu naught H, and in the denominator numerator H cancels, so it becomes mu naught N E square summation R square by 6m. So chi becomes minus mu naught. Chi is susceptibility. So psi you know, that is for wave function. So this chi, slanting x athwa curly x, so this is a susceptibility symbol chi. This is minus mu naught Ne square summation r square by m. So chi is equal to this. So we replace sigma r square by average r square mean square distance, because all electron orbits are oriented in different directions. From the field axis, effective distance we take, that is average expectation, average value of r square, that is the from the field axis. Therefore, chi is minus mu naught E square by 6m n z. Z is the atomic number. So total number of atomic number. So you know that total number of positive charges inside the nucleus. There, that also says that it is the number of electrons, so that total number of positive and negative charges are same. So Z gives you the number of atomic number, and N is the total number of atoms in the electrons in the atom. So minus mu naught E square 6m Nz and average value of R square. So if you look at this equation, so chi susceptibility is negative. First thing is susceptibility is negative. So this is the characteristic of diamagnetic materials. So diamagnetic materials have negative susceptibility. So we have arrived at expression. This expression gives us that chi is negative. And also there is no temperature term. So for diamagnetic materials, chi is independent of temperature. See, chi is independent of temperature, and B also field strength. So chi, that is susceptibility, is negative, which is diamagnetic material, property of diamagnetic material. Chi is independent of temperature, that is also property of diamagnetic materials. And this expression we have derived, that is susceptibility chi is equal to minus mu naught E square by 6m nz, and average value of R square is the that is the Langevin's expression. Derivation means you have